Every building has one simple job when it comes to water: keep it out. But here's the reality: water is going to find a way in. So our buildings need a backup plan. If water gets in, let it out. So let's take a moment and break down exactly how water moves and why understanding this matters for every home inspection you do. Think of your building enclosure like a raincoat. First priority, keep the rain off you. But what happens when moisture gets past that outer layer? You need materials that can handle it and dry out. Buildings work in the same way. Multiple lines of defense, not just one perfect retarder or barrier. Water is sneaky. It doesn't just show up as rainwater hitting the roof and then sliding down. Water can enter buildings in several different ways. Here are the 4 main forms of water, and each one is differently. It behaves differently. First, there's liquid water. That's your obvious stuff, right? Rain, plumbing leaks, groundwater. That's easy to spot when there's a problem. The second form of water is solid water. That's ice. Think of ice dams, freeze-thaw cycles, frost. Ice expands. That expansion can crack, move, damage building materials. The third form is water vapor. That's invisible moisture in the air. This one's tricky because you can't see it, but it's constantly moving through your building envelope. Fourth, here's where it gets a little interesting. Adsorbed water. That's water that clings to surfaces like a thin film. And let me clear something up that confuses a lot of home inspectors and contractors. Absorption versus adsorption. One is spelled with a B, absorption. The other is spelled with a D, and that's adsorption. And they're completely different things. Sound the same, completely different. Absorption is what you think of with a sponge. Water soaks into the material, filling up the internal structure of the sponge, and the water becomes part of that bulk material. Adsorption with a D is surface level. Picture condensation on a cold glass of water. The water molecules stick to the outside surface, but don't penetrate the material itself, right? It's like a thin film clinging to the surface. Why does this matter? Because building materials handle these 2 types of moistures completely differently, and your inspection process needs to account for both. Here's something that trips up a lot of inspectors and contractors: the language that we use. We've got air barriers, vapor diffusion retarders, permeable and impermeable, and everyone seems to use these terms a little bit differently. Contractors, building officials, manufacturers, we're not all speaking the same language sometimes, and this creates real problems when we're trying to write a written inspection report and communicate our observations with other professionals and clients, trying to explain the defects that we see. So let me give you the 2 most important terms that we can get right? Vapor retarder retards or slows down the movement of water by vapor diffusion. It doesn't stop it completely. It controls the rate of movement. Now, you might hear people say vapor barrier, but that's old school. Old school terminology we don't use anymore. Why? Because true barriers don't exist in the real world of construction. And thinking in terms of barriers can lead to moisture problems. We dig deeper into this concept of barriers and retarders in the moisture training course, because understanding how moisture moves is the foundation for everything else we'll cover in InterNACHI's training. Once you grasp the basics, the terms like PERMs, vapor retarder classes, well, everything else will make perfect sense. You'll understand why different climates need different approaches, and why some building details that look wrong might actually be right for their specific situation. Remember, water is always moving, always looking for a path of least resistance to move. And our jobs as home inspectors is to understand those pathways and to spot when the building's defense system has gaps. So let's dive real deep into how moisture actually moves through buildings.